All right, so let's do this and see how it turns out. So again, I'm here for the exercises that are on pages 12 and 13. We're looking at the bottom for the examples that we're going to do in class today. So make sure you're on this side. Now, the two that are up there at the top, they're asking you to do the same thing as related to what we talked about in notes yesterday. So the first part, it says list all pairs of congruent angles and write a proportion that relates to the corresponding sides for each pair of similar polygons. So I'm going to get you guys started on this. First off, if you have angle D, it's going to be congruent to angle G. All right, good so far? Now, there are two other statements that you're going to make with congruent angles. So I'm going to give you a minute to fill these in, but you'll have two more sets of angles to add to this. And then the other part of this is it wants you to write proportion. Well, we're talking about the sides when similar figures are proportional. So again, all the angles have to be congruent, all the sides have to be proportional. So since it's a triangle, there's going to be three sides that are going to be the same. So take a minute and see if you can come up with three fractions. And I'm going to give you the first one. So we're going to have DE over GH. DE over GH. That's going to be the first fraction. So take a minute, see if you can fill in the remaining angles that should be congruent, and then see if you can fill in the other two ratios. Oh, I made one mistake. I'm sorry. Right here where we have that should be not a comma, that should be an equal sign. I'll fix that in just a second. But again, on your papers, go ahead and fix that. That should be an equal sign between those, so that is a proportion. Again, all those should be equal. Let me fix that. Yes. Oh, you kept my pen? All right, I'll come get it from you in a second. I'll get you a different pen to use. That's my pen, and I don't want to lose that pen. I can give you pencils all day. No, don't take my pen. Is there anybody who did not get the seating chart too? Everybody else got a chance to check out the name? Huh? Thank you. let's go through these couple. So on that first one, we had D was congruent to G. E would then be congruent to what? H. And what's the last one? F and J. Now, did you look over here at the figure to do that? No. Is there anything marked on the figure? No, the figure's not really telling us anything right now. So where do you actually have to look in order to figure this out? The statement. Yeah. So on here, triangle DEF is similar to triangle GHJ. Just like in our congruency statements, our similarity statements have to be written in corresponding order. So when we say all the angles are going to be congruent, well, they're the ones that correspond. So D and G, E and H, F and J in corresponding order in the statement. So those are the ones that correspond to each other and are congruent to the figure. Now, as far as these statements go, so when we're trying to write the proportion, we have to have the same ratio set up each time. So when I set up the first one, I did DE, which is from the first triangle, over GH, which is from the second triangle. So each time you need the first triangle on top and the second triangle on bottom. So give me one set of values that I could put in a fraction. What did you say? EF. All right, we can go with EF. And if I did EF on top, what can I put on bottom for that one? H. H, which one? H, not E. J. So here we had E and F, which were these two. So H and J in the same corresponding positions. All right. Now that one works. There are several different ways that you could actually write that though, because does the order that you write them on top or bottom matter? No. So like this EF could have been FE. This HJ could have also been JH. So you could have written that one of several ways. But what has to be true is those two letters had to be on top. And if those two letters were on top, those two letters had to be on bottom. So again, the order in which those letters appear didn't matter. So now, the last set. What two letters had to be on top of the last statement? F and D. And again, doesn't matter the order there. And then on bottom, if F and D are on top, then what's on bottom? J and G. Again, doesn't matter which order you put them in on bottom, they just have to be the same corresponding two parts. All right. So FD could be on top and GJ could be on bottom. DF could be on top and JG could be on bottom, or DF could be on top and GJ could have been on bottom. Again, there's different ways you could write that, but the same two letters have to be on top, same two letters have to be on bottom of each of those fractions. All right. Questions? Yes. All right. On this one, we're going to do the same thing, but I'm going to change what I'm asking for. I'm not going to put them in order. So if you already did it, great. If not, again, try doing the order that I'm giving it to you. So I'm going to have angle P. You know what's congruent to that one? Angle W, what's congruent to that one? Angle U, what's congruent to that one? And angle. All right. So I want you to write which angles are congruent to each of those. And then over here, I'm going to give you UW on top and QR on bottom. And how many statements should we have this time? How many actual ratios? 4, because there's 4 sides. So there should be 4 different fractions that we write for this one. So take a minute to do that.
Is this a UW over QR?
UW over QR. Yes. This one warm. Yes. That picture, I'd say the longest my hair ever got. Slightly shorter. Slightly shorter. So it is. It's not like that. I'd say a little bit longer. Yeah, where it is to the side, it's like a- I think I have been working out of this. See that? I think back when I was cartoons. Oh, yeah. Not what? 50s? 60s? Very nice. Maybe 30s? 38. Close. I'm
You're 36.
37. You like that, yes. I'm not one to eat there. No, if you look at the rest of my family. By the time they were grandparents, by the time they were 40. Well, that's why I changed my head. You don't go back at all? You don't go back at all? I'll probably shave it by the next week. All right, let's finish going over these tables. All right, on number 2, we got, yes, all right, focus. All right, you had a chance to do these. Now, going through them real quick. For the first one, P was congruent to what? T. W was congruent to what? R. U was congruent to what? U. And S was congruent to X. Good. Now, going over there to the ratios. Again, as long as you have the correct letters, there's the correct letters on bottom, they're good. It didn't matter where you put them in order, as long as you have the same correct 2 letters on top of the 2 letters on bottom. So I have UW already here. Now, since I started with this one on top, every single one of these fractions should start with these letters on top from the second figure. All right. So I have UW on top. Let's say then if I did TX, then I need P and X. Then if I had T and U, then I need P and Q. If I did W and X, then I need R and S. Again, I'm using that statement to help me match those up. All right. Down to number 3. Do you think those 2 figures are similar? So are those figures similar? Why or why not?
No,
No? All right, why not?
they're not the same.
They're not the same shape. All right. What about them that's labeled makes them not the same shape? Because I think you're right. All right. Well, all these sides on this one are marked as congruent. On this one, are all the sides marked as congruent? No. In fact, there's actually 2 sides. This side, JK and LK, both missing congruency symbols. So definitely not going to be proportional there. All right. Also, if you look at angle L, there's a right angle symbol. Are there any right angles in the first diagram? No, all the angles, all the corresponding angles have to be congruent. So these two aren't gonna work. Now, on number 4, are those two similar? Are they similar on number 4?
Yeah.
Yes, all right. So there's two different figures there, and they're overlapping. There's two triangles. You see the small triangle on top, and then the big triangle that you see the whole thing. Those are the two shapes that we can say are similar. All right. So first, we have to write a similarity statement. Now, when I write the similarity statement, I'm going to write these two triangles are similar. Does the order in which I put the letters for the first triangle matter? No, I can write them in whatever order I want. So let's start with the small triangle. I have the letters R, Q, and P in that first triangle. What order do you want to put them in? QPR, all right. Yeah, Q, C, R. Now, once I wrote the order for that first one, does the order for the second one matter? Yes, now they have to be in corresponding order. So since I started with Q, what's the first letter I'm going to have to write for the big triangle? S. Then, since I went to P next, where do I have to go for the big triangle? Also B. And then, since I went with R last, that's going to be T. Now, I think in every single class, I think I did a different order. And that's fine. The order that you put them in doesn't matter. All right, for the first one. Once you have the first one done, then the order for the second one does matter. So you just have to make sure you match it so it's in a corresponding order. All right. Questions on that first page? All right, on the second page, we're combining ideas from the notes from yesterday and then the notes from Friday. So we're saying up proportions for similar figures, and then we have to solve them. So again, there are some notes on the top of the page. I'm going to go over 3 of the examples from the bottom of that page. So now we're looking at page 13, down on the bottom. Let's look at number 1 first. So in number 1, now it's hard to tell at first glance if those triangles are similar, but if you look at the directions, they told us each pair of polygons is similar. So they told us in writing that those two are similar. So we know that they, for in fact, are similar. Now, they face different directions. So we have to figure out how we're going to set up a proportion using these. Well, they did label 2 of the angles for us at least. So that's going to help us align which parts are congruent. Now, in the first diagram, we have this 10. What side would that go with over here? Is there a side that would match with a number? The long side. Well, is there a number there? No. So we're not going to be able to use 10 right now because there's nothing there for us to use it. All right. What about the 8? So now look at this 8. Is there a side that matches up with that? So look at what side it's on. Notice it's next to the one with the 1 mark on the angle. Which one does it go with? 12. So these two can be put in a ratio with one another. I'm going to say 8 over 12. Now, for x, that's the one we're going to have to solve for. What if we have to match that one up with? The 9. So these two are going to go together. So we're going to have 9. Should we put the 9 on top or bottom? Why do you say bottom? 12 on bottom. So on here, we did little triangle to big triangle. So we have to make sure we keep it the same. So over here, the x is for the small triangle, the 9 is for the bigger triangle. We have to go in the same order. Now that we have them set up in the same way, we can do what we did on Friday and solve a proportion by cross multiplying. So we are going to multiply the 9 together and the 12 and the x together. So 8 times 9, 12 times x. What's 8 times 9? 72. All right, now we have to solve. What do we do? How do we get x by itself? All right, so divide off the 12, and we get what for x? Whoops, I just ignore what I just wrote for a second. What do we get for x? 6. Sorry, I have to start writing the answer when I ask for it. So that's all we have to do. We have our answer, and that's all they asked for was x. All right, let's go over to number 4. A little bit more challenging when we go to solve this one, but setting it up, we at least have values in the same position. So on this one, again, I have this 36 over here. Do I have anything to match 36 with in the second diagram? No, it's missing. There's nothing over there. So again, that's extra extra information that we can't use right now. All right. A lot of times in these similar figures, they're going to give you a piece that's extra to try to throw you off. So make sure you're setting up good ratios using parts that are corresponding. Now, on the bottom, we have 40. Again, the triangles are set up the same way here, so 30 would go with that 40. These are much bigger numbers than what we're dealing with on the last one. So I can say 40 over 30, but when I go to cross multiply, do I really want to multiply by 40 and 30? No, that's going to give me really big numbers. So what could I do with those? I can simplify them. I can reduce them. All right. Both of these are divisible by 10. So that's the same thing as saying 4 over 3. And if I was to reduce this value that I reduce it down to, this is what we can actually call our scale factor. So 4 to 3 is a scale factor between these two figures. And I can use that scale factor instead of using one of the sides. So now I have 4 over 3. And I need to solve for x. So on this side, I have x plus 15. On this side, I have 18. Again, which part of that do I put on top? The x plus 15. Why? Because I put the 40 over top. So I put all the values from the bigger one on top. So I have to do that same standard over here. So put the smaller ones on bottom. Whatever you do in the first fraction, you do the same thing in the second. So this time I chose to put the bigger figure on top. So I put the smaller figure on bottom. And I have to do that for every ratio. All right, once you do that, this looks like one of the problems we did on Friday. We have to cross multiply. But when we cross multiply on this one, there is a little bit extra work because this 3 is going to have to go to everything. We're going to have to distribute. So we have the 4 times 18, but plus 15, right? So the 3 is going to have to distribute to both of those. Now, once we multiply this out, we'll be able to solve. So let's go ahead and multiply everything. We got 4 times 18. What's 4 times 18? Everybody? 72. The 3, multiply it out. 3 times x is 3x. 3 times 15. Keep your hands to yourself. All right. So we have 3 times 15 is 45. Now, we need to solve it. So we got to get x by itself. What's our first step? Minus the 45. So subtract 45. That brings this all the way down to 27. What do we need to do now? What's our last step? 5. Divide off 3. X is 9. All right. Okay. The last example that we're going to do, number 5 down there. Now, do you have enough information from the diagram to say that these are two similar figures? What do you think? Yes or no? You haven't done one like this yet, so it's all right if you. What do you think? Yes or no? Yes. Yes? Who says yes? Oh, come on. Yeah, over there. Pay attention, will you? Who says yes? Do you think these two are similar? Is there enough information just off the diagram to say they're similar? Say yes? Yes. All right, who says no? All right, just looking at the figures. How many parts do we know on this figure? We actually know all 4, right? Because if that's 20, this is 20, if this is 14, this is 14. On that one over there, how many parts do we know? We know 2. We know this is 25, so this one's 25. Do we know anything about this other set size? No. So just looking at the figure, we don't have enough information. All right. But look at the words. What are they telling us? What are they telling us? What does this actually mean? Again, that's our symbol for similar. So even though they didn't say it in writing like they did on the last one, like where they had up here, the polygons are similar. Down here, they gave us it as a statement. That's just as good as saying in words that they're similar, because that symbol in the middle means similar. So we know they're similar. So now we need to find the scale factor, and we need to find the perimeters of both. Well, first off, the scale factor between these. What two numbers am I going to compare for the scale factor? What do you think? What two numbers can I match up? Why 20 and 25? Remember, these figures might not be drawn to scale. I'll tell you, it is correct. 20 and 25 is correct. I need a reason, a good reason as to why we can match those up. And it's not the fact that they're both on bottom or they're both on top. Think about what we've already done today. What do you mean by corresponding? How do you know they're corresponding? Because again, the figure, we don't know which ones correspond based off that figure. How do we know that those are the two that correspond? Statement. Again, go back to the statement. C and D, if we look at the statement, are at the end. So R and S are at the end, they're in the same corresponding position. Again, I always go back to that statement because for all we know, they could have flipped this on its side and drawn it not to scale. So you gotta be careful. All right. This one we can simplify. Both those are divisible by 5. So this becomes 4 over 5. This is our scale factor for that diagram. All right, that's our scale factor. So they're in a ratio of 4 to 5. Now, the other part, they ask for the perimeter. Well, do you have enough information right now to find those missing sides? No. But can I find the perimeter at least for this first one? Yeah, the first one, I have all the sides. So if I add every single side up, what do we get? Got 20, 20, 14, and 14. Total of 68. Yeah. So perimeter for this first one, I'll call perimeter 1, is 68. So we need the perimeter for the second. I'll call it P2. Even though we don't have all the sides, yesterday I said all of the corresponding parts that are single dimensional units are going to share that same scale factor. So perimeter was included. So since we have a scale factor and we know the perimeter of 1, we can use that to find the perimeter of the second one. Now, 68 is a big number. If I set up a proportion here, where does 68 go? On top and bottom. Top, and bottom. Any reason why? Yes. Okay, so it's going to be on top because the 4 is coming from which of the figures? Small figure. Even though this is a big number, a very common mistake on this sort of problem is, all right, that's a much bigger number, throw on the bottom of the bottom number. No. Again, you got to keep in mind, which one did they come from? The 4 and the 5 here, this is from the smaller figure. So the 68 is from the smaller figure, it also goes on top. We should be getting a bigger number for the second perimeter, right? So that must be the one that's on bottom. Now it's same as the other problems, cross multiply and solve. So you have 4 times P, and you have 5 times 68. What is 5 times 68? 5 times 68 is 340. This one, did you use the calculator? Yeah. Well, I asked because with 5, there's an easy trick to multiply by 5s. If it's an even number, all you have to do is divide it in half and add a 0. Let's see, what's happening? 68. 34. 0 on the end, 340. If it was an odd number, again, you can still divide it in half. You're going to get a decimal. That's going to be 0.5. So just remove the decimal. All right. You can do that with any number and multiply by 5. All right. So we got 340. Now we still got to get rid of that 4. So divide off 4. And the second perimeter is what? Oh, we're going to get an answer. What's the second perimeter? So 85. Huh? Any questions from what we went over today? Again, the remainder of that paper is what you have for your assignment. So again, there is a spot on Canvas to turn in. The due times are not correct yet because I just put up there at the end of one period. I didn't have time to do and set the correct due times. Again, it'll be 5 minutes into class tomorrow, but it is open for you guys at least right now to turn into. All right. Any other questions? I'll have to look at the thing. I don't remember off the top of my head.
This is one?
Yep. So the other side, it's pages 14 and 15 on that worksheet. That is your homework assignment.
Uh,